Okay, so this video is going to look at the 3Ps of natural hazard management. So we might get a question like the one that we've got up here. Assess the effectiveness of prediction, planning and protection, there are 3Ps, in reducing the damage of said hazard. This may be a tropical storm, it may be a volcanic eruption or an earthquake. Now there are two really important things to consider here. Firstly, whenever we're asked to talk about the effectiveness of prediction, planning and protection, even if really the command word isn't assess, okay, I would like you to look at trying to rank and justify your thoughts on them, saying which one of the three you think is the best. On top of that, we need to consider as well that which one of those is better, which one you would rank as the most effective, is dependent on the type of hazard. For example, a volcanic eruption prediction is going to be much more effective in reducing the potential risk than it would be for a tropical storm. So let's start by looking at how these 3Ps can be used in reducing the risk posed or the damage caused by a volcanic eruption. What we've got here is kind of a little podium set up, okay, because in my opinion, and the easiest way to write about this, is prediction is the most effective in terms of reducing the risk posed by a volcanic eruption, closely followed by planning, and lastly by protection. Now, if we actually look at these in a bit more detail, prediction of volcanic eruptions is actually something we are relatively good at. Okay, for example, we are able to use things such as measurements of radon and sulfur dioxide that are released in the build-up to a volcanic eruption in the atmosphere surrounding the volcano, and those levels of these gases increase as the volcano nears eruption. In addition to this, we also sometimes see as magma below the surface moves around in the build-up to a volcanic eruption, we can sometimes trigger small earthquakes that can be picked up using seismometers that again give us indication of a potential eruption. On top of that, probably one of the most accurate ways we can do it is using altimeters. These are satellites in space that can actually measure the height of the ground, and advances in technology have allowed these things to become incredibly accurate. They can measure the height of ground to within a millimetre. And as magma starts to build towards the surface in the build-up to a volcanic eruption, that will cause a slight bulging of the Earth's surface that can be detected by these altimeters. Now, prediction on its own doesn't actually prevent any damage or deaths caused by volcanic eruption, but what it does do is it allows people time to evacuate the area. Again, that is actually what saves lives and therefore reduces the potential impact. That then closely links into our second most effective element, okay, which is planning. When we plan for a volcanic eruption, we will do things such as making sure that people in surrounding volcanic eruptions have an evacuation plan and know their evacuation routes. There'll be designated roads that will be signposted as volcano eruption evacuation routes, and people will follow these so that not everybody goes in the same direction, causing gridlock and preventing people from being able to evacuate. Also, people and local authorities will ensure that they have emergency shelter, food and water provision, so that if anything like water sources are contaminated, that we won't worry about things like diseases spreading. Also, following on and looking at previous eruptions, authorities can start to designate places of exclusion zones, but areas that in the past have been particularly badly affected by volcanic eruptions, and therefore maybe would be obviously a good idea to avoid those areas, so we don't build in those, people aren't allowed in them, they aren't allowed to use those areas of land. That obviously then means that they aren't at risk. Finally, as I said, protection is probably the least effective. It is very difficult and incredibly expensive for us to protect against volcanic eruptions. There are certain things we can do, such as there have been cases where very expensive heat-resistant sort of tiles have been used to create walls to direct lava flows away from residential areas. But as I said, these are incredibly expensive and not always successful. So moving on to earthquakes, we've still got those same 3Ps, but this time a slightly different order. This time prediction is now the least effective, coming in third, and really we've got interchangeable. It's easy to argue that either planning or protection have similar importance in reducing the threat or risk posed by an earthquake. So I put planning up there as first, but in the exam you could quite easily, as I said, argue that protection is more important. Planning allows for an organised and effective response. It allows emergency services and local people to know what to do in the event of a disaster and therefore respond to it more quickly and more efficiently. For example, people in earthquake-prone areas will normally have emergency earthquake kits in their homes. This will provide them with basic things like emergency water, tinned or dried food that they can eat in case they're trapped in their homes or unable to get supplies. At the same time, governments, normally in high-income countries because they can afford it, will store things such as emergency food and water supplies in large quantities in case, for example, the major water supply, the main supply is cut off or damaged. This obviously stops the spread of diseases like cholera, which is really prevalent in low-income countries after natural disasters. Also, in schools, in the UK, we do things like fire drills. Okay, they will do earthquake drills, so children will be educated on what to do in the event of an earthquake. Therefore, again, hopefully meaning that if one does happen, the risk it poses to them is less, as they will know what to do. Japan have also invested in designing apps. These apps will automatically take over your phone if an earthquake warning is triggered, and as a result of that, it will then direct people to their closest evacuation centre and provide them with a safe route to these shelters. Okay? Therefore, again, meaning that people aren't at risk for as long and have got kind of support around them. We then move on to protection. I said really quite important. We can actually protect against earthquakes if we have the income. Again, this is where we see that low-income countries suffer because they maybe can't afford to make the earthquake-proof structures and designs that high-income countries can. So one of the really common things that we see is earthquake-prone areas, if they have to build large tall buildings, they build them with a very wide base. The Transamerica Pyramid in San Francisco, for example, is a perfect example of this, much wider at the top, giving it a much more solid structure. The buildings will also have shock absorbers in their foundations, which allows the building to move slightly with the movement of the ground and counteract that movement. Again, the Transamerica Pyramid in San Francisco has been known to move by several feet, up to 5 feet left to right in the event of an earthquake. To help with this, they normally have a counterweight and rollers on the roof. This counterweight is on tracks and it moves in the opposite direction to the ground movement to try and counteract that movement. Other things, the buildings may be designed to have reinforced steel structures or bracings up and down the sides, things like reinforced steel cables on lift shafts so that these aren't broken or damaged if anybody's caught in the lift during an earthquake. And they also normally have shutters that come down over the windows to stop any broken glass falling out onto people on the pathways below. On top of this, they normally have large open spaces around them so that people can evacuate, and if one of the large buildings was to collapse, it wouldn't cause a domino effect, knocking several level ones over. As I said, prediction is probably the least effective here. We actually generally aren't particularly good at predicting whether or not an earthquake is going to happen. We do know where they're going to happen. We can look at historical records and see where earthquakes regularly occur, generally at destructive or conservative plate boundaries. But we're very have limited accuracy in terms of when they're going to happen. As a result of this, predicting earthquakes is very difficult. This means that when we do, sometimes it may not actually happen. And what we see is people start to ignore warnings after they've maybe evacuated their homes for previous times when an earthquake actually hasn't happened. Some of the things that we use to predict an earthquake are things like foreshocks. Okay, so small earthquakes in the build up to it. The problem with these is that they do normally happen pretty close to the major earthquake, therefore not given enough time to evacuate as kind of like a volcanic prediction would. Also, we can look at frequency patterns, so we can look historically and see how often earthquakes have happened in the past and see if there's a cycle. This does work in some places, but there are also parts of the world where there doesn't seem to be any pattern. We've even gone as far as looking at animal behaviour. There are historical records where animal behaviour has seemed to go quite strange in the build-up to an earthquake, resulting sort of in some scientists to believe that animals can detect kind of seismic activity. But again, this is a very vague science and not exactly one that you want to be suggesting massive evacuation of a city on if it then turns out to be incorrect. And then finally, we want to look at tropical storms. Again, we still got our same 3 Ps: planning, protection, prediction. This time, our order of them in terms of their effectiveness, again, we have this idea of planning and protection being interchangeable for first place. And again, this time prediction, unlike with the volcanic eruptions, but like it was with the earthquakes, being in third place, being the probably least effective. Planning is very similar for a tropical storm as it is for an earthquake. Okay, people will be given drills and education on what to do in the event of a tropical storm. There'll be evacuation routes set up so that people can evacuate their towns if they're given warning that a tropical storm is on its way. Again, these evacuation routes will be designed so that the movement of traffic is kind of spread across the road network so that there aren't gridlocks, so that people can get out of the area. People are instructed to also have fuel in their vehicles because maybe the fuel supplies will have to be cut during the storm, and there'll be emergency food and water supplies provided by local authorities, and local people will be encouraged to stock these in the case that the water supply is damaged. Protection-wise, again, we can design our buildings to be sort of hurricane or tropical storm proof. We can have hurricane straps. These are galvanized metal straps that connect the roof to the sort of walls and major structure of the buildings. This prevents the roof being ripped off by the high winds, which is obviously a major threat to humans and inhabitants of those houses. Also, we have storm shutters, so large metal shutters that come down that stops the windows being smashed if something is blown into them. Okay, and obviously people are also encouraged to make sure that loose objects, particularly out in the garden, things like garden furniture, are either tied down or weighted down so that they can't be picked up. We can also kind of protect against the threat of the storm surge. We know that when a tropical storm comes in, the low pressure causes the sea level to rise, and the really strong winds can push very powerful waves inland. So making sure that low-lying areas are protected either by flood defences like seawalls or mangrove swamps, those trees that kind of grow in that kind of area between the sea and land. What they can do is they can absorb the energy of the storm surge and the wave as it comes in. So it's a very natural looking protection. And what we're seeing in places like the USA is that we're seeing kind of a reintegration of mangrove swamps that had been taken away to make room for building land, so being put back in place due to this protection that they offer. As we said, prediction is probably the least effective here. Now, we are better at predicting tropical storms than we are hurricanes. We can use satellites and drones to gather data. So the drones will be like automatic planes without pilots that will fly actually into a hurricane and pick up things like the wind speed and the air pressure and so on. That data then can be put into supercomputers, which can predict the storm intensity and track of the storm, so the route it may take. Okay, and that normally produces something that we call a storm or hurricane cone. So what we have is a hurricane on day one, and then the computer predicts where it thinks that storm will go over the next few days and how strong it will get. However, if you notice, our cone is getting wider here because the further the computer has to predict into the future, the more it's sort of this unpredictability in how the tropical storm will move. That is one of the major issues. Tropical storms, though we can predict roughly where they go, they can make sudden and kind of unexpected changes in direction. So we have to create a kind of greater margin for error the further we predict into the future. The major problem with this is that, a bit like with the hurricanes, if people are kind of evacuated from an area because they've been given warning about a tropical storm and then it doesn't happen, over time they may become kind of tired of this and decide to ignore future warnings.